This is for Math 127 OE1, or just open enrollment. Looking at a couple of problems from 8.2, and we're talking about specifically the tangent graphs, tangent and cotangent graphs. So what we're trying to do is figure out what's going on with how to identify the function from the graph that we're given. So the first thing, and I did pull this from someone's work, and you'll see that the person got some stuff right. That's great. So this type of curve, trying to identify what the graph's going to be, knowing that it might be a tangent and cotangent, that if we jump over here and just take a look at Desmos, that if we look at f of x equals tangent x, we get these curves like this. And if you pay attention to some of the lecture or some of the lessons, that our tangent is going to go from negative pi over 2 to pi over 2, because that's where cosine is 0, which makes it undefined because it's tangent is sine over cosine. So roughly here, oops, let me get this. I guess I can't draw on this screen. I can't draw on a Desmos thing. So I wonder if I can say y equals pi, no, let's say x equals, pi divided by 2. And then we'll do x equals negative pi divided by 2. So I'm not trying to drag out. I know someone asked for some answers. I'm trying to get some understanding of what we're dealing with here. So we see that there's one period of a tangent function. So if we come back to this, and the first question is, what is the period of the function? We see it goes from negative pi over 4 to 3 pi over 4. If we do 3 pi over 4 minus a negative pi over 4, that's 3 pi over 4 plus pi over 4, which is 4 pi over 4, which is pi. And that's what this person had. Very good on that one. Now, what is also important to do is recognize in a graph like this some crossing points. And just if you understand what that shape looks like, let me come back over here to Desmos for a tangent curve. And this one is crossing along the x-axis, so y equals 0. I call that the crossing points, or just kind of that central region of the graph. So again, if someone out there in YouTube land doesn't like my terminology, I get that, and maybe not being as precise as it could be, but what I'm just trying to get across is where is something like that happening, and we see it here. It's happening on the line y equals 2, which implies a shift vertically of up 2. And so that's where we have, this person got that correct as well. Good job. Now, the next question is, what about a vertical stretching? Now, it's easy to see that stretching. I'd say easier to see the stretching on a sine and cosine function, for example. But in a graph like this, where it's going negative infinity to infinity, not so easy to see. But normally, like if I go back over here to my tangent, we know that, let me put in x equals pi over 4. So I want to point out here that right about here, that's 1 for the y value. So at pi over 4, we get 1 for tangent. And at negative pi over 4, we're going to get negative 1. And we should know that by now with some of the values, but just in case you didn't. So meaning that this here, that it crosses that kind of whole number from this value to this value, that's a growth of 2. Normally that'd be a growth of 1. So that tells us that our amplitude is 2. And normally that would be down here, be down to this area, but it's up there. And normally this would be here, but it's down there. So it's stretched by a factor of 2. So let's say 2 for that. And then we're going to put this all together to come up with our equation of the graph. So f of x equals 2 tangent of x plus 2. And that's it. So let's go to the next one, which is number 4, and try to identify this. So when I first look at this, my gut tells me, it jumps out to me, oh, it's a tangent because of this shape. You know, it's going up like that. But if I were to turn the tangent off, cotangent on, and let me turn off some of these things as well. You know, it's not going the same direction, but it could be an inverted cotangent function. So here, the key thing to look at is along this y-axis, that's a vertical asymptote, as is pi. So I'm going to change this to just a pi. And x equals pi, so I'm not going to graph it for me. Oh, turn it on. There we go. And so you see pi and then x equals 0 are asymptotes for that. So there's our clue, but I believe you could have turned that on. I mean, you could try to do this as a shifted tangent, because obviously cotangent and tangent are co-functions shifted by pi over 2. So let me go back over here. And so the clue to me on this was the fact that this x equals 0 is an asymptote here. So if that's an asymptote, we can go with an inverted cotangent, meaning we'd have something like y equals something negative times some cotangent x plus something might be shifted. And also looking at our values here, we might have a different period. Looks like the period is going from 0 to 2, then 2 to 4, so it looks like we have a period of 2. And normally the period is going to be pi. So given the period of the function whose graph is shown above, I think it looks like a 2. So that's going to give us a different b value. And then we're going to look at the positive vertical stretch. So in this case, when I'm talking about the center values, and it was normally on the 0 line here, looks like it's down here now. Looks like that's our center line. So this is coming down by 2. So our c equals negative 2. And that's actually a question down here. But it's helpful for me to see that before I go to the vertical stretch. And here we're going to look for a value. It's going to be a little tougher with this one, given that we have a period that's not pi. So the period is going to be pi divided by b. So our period is 2. So 2 equals, let me fix what I was writing. 2 equals pi over b. So I'm going to flip both sides. So 1 over 2 equals b over pi. So b equals pi over 2. And that's, let me come up here. That would change this part here. We're going to have a pi over 2x. Now, the last thing then is talking about that vertical stretch to see what's happening. And some important values. So we'd have something happen normally at like pi over 4. Cotangent pi over 4 is 1. And, but this is inverted. So we're going to be coming down instead. I got to think about that. what would that be? Pi over 4 divided by pi over 2 would be pi over 4 times 2 over pi, which is 1/2. So at 1/2, which is where that would be, so that's really 1/2, it's going to be doing something. And at 1/2, it looks like we're right about there. Normally it'd be going down by 1. I mean, when I say going down, this is because it's an inverted cotangent. Normally it would be down here at 1, but it's down here 3 below. So that implies to me that we have a shift of 3. So our A would be 3. And then likewise over here, if we looked at 1.5, which normally that would be 3 pi over 4 divided by pi over 2, which is going to be 3 over 2, which is 1.5. If I look up a little bit, right about there, and again, that's a shift or that's a stretch of 3. So that's going to be a 3 here. Again, the negative is because it should be coming down like that, but it's going up like that instead. So coming down here, this is going to be 3. And our overall function is f of x is equal to -3 cotangent of pi over 2 times x. I have that in parentheses. You can either say plus -2 or -2. And that's how you do those problems. So I know this took a little bit longer. Trying to decipher what's in these graphs is a little bit of a challenge. So I hope that helps.